what it means for an angle to be in standard position, what we call a terminal arm and a terminal point, and come up with recognizing what something is in standard position. And they got a picture of an angle in standard position in quadrant 1. So I'm going to play a little game. I'm going to put, I'm going to put yes here and no over here. And I'm going to draw an angle. And we have to decide, is this in standard position or not? And once we've done a couple, and you can guess, you think that one is yes or no? Some no's, some yes. This one actually is in standard position. Okay, I'll give you another one. How about this angle here? This one is no. Okay. Slide it over here. That's a no. How about right here? This one is actually a yes. How about this one? That one is actually a yes. And the crazy, you probably didn't even notice it, but when I did that one, I actually put you in a hypnotic state. You're currently all in a state of hypnosis, which is kind of crazy because I can do all sorts of influential things right now, which is kind of dangerous. When I snap my fingers, you're going to come out of it. You won't remember anything that happened. But you're going to go home and be like, oh, I like math. And you'll be like, I feel like I should do, I kind of feel like doing math homework. You won't know why you have those feelings, but you might notice that over the next couple of weeks that you're just like doing more math homework than normal and you won't know why. So it's a good thing, but I'll snap my fingers. If you want to know what just happened, you can watch the video later. Yeah. And yes or no? That one is a no. So we've done 5. I don't know if it's enough, but what we want to do is see if you've seen a pattern. What happens in all the yes ones that makes it an angle in standard position? What do you see? It starts on the positive x-axis. That's the key thing. And the reason we have a standard position is so that when people communicate things, they understand what's happening. Oh, I have an angle of 100 degrees in standard position. If I tell you that, then you should be able to say, oh, they said it's in standard position, so I know it starts here. There's 100 degrees. I have an angle of negative 20 degrees in standard position. They're like, oh, it starts here and negative goes in this direction. That's an angle in standard position. So we have standards so we can communicate well. So first of all you need to write down an angle is in standard position if it starts on the positive, not the negative, so we should have probably had an example here. This is another no. It starts on the x-axis, but not the positive x-axis. And then also on this page, before we get to our examples, this year you're going to be expected to do some trigonometry without your calculator. Do you know any angles without your calculator? Any ratios? Do you know what tan of 45 is? Close. It's 1. Check it out on your calculator. Type in tan of 45. And we have to figure out how to do this without our calculator. Because tan of 45 is 1. Well, sine, cos, and tan are all based on right triangles. So if I want to figure something out without a calculator, I draw a right triangle, which means that's 90 degrees. If I want to figure out 45 degrees, I make one of the angles 45. What else do you know about that triangle? Is there anything else you could figure out? So all of our angles have to add up to 180, so what does that make the other side? 45. Okay. And then that makes it special. There's a special name for that triangle. Besides a right triangle, it's also another kind of special triangle. 45, 45, 90, but what do we call the triangle if two angles are the same? You know the name? Isosceles. And if it's isosceles, two angles are the same and two sides are the same. This is really important. The idea of trigonometry is your trig ratios, which are built into your calculator. They don't matter how big or how small. Like I can draw this triangle with 45 degrees this size. I could draw it way bigger. I could draw it way smaller. But apparently, the ratios always have to be the same if you have the same angles. So if these sides are the same, we could have drawn it, like how long do you think that side is? Well, we could say x, but if you picked a number, you could pick any number, right? Sean, pick a number. 3. It could be 3. If this side is 3, then if the two sides are the same, the other side has to be 3. Now think about tan, because I just said, I want to figure out what tan of 45 degrees is. Tan is opposite over adjacent. If I chose 3, I would get 3 over 3. Do you see that that's equal to 1? What if you chose a different number? If you chose 10, would it still be equal to 1? Any number that we choose is equal to 1. Most often when we draw this special triangle, people actually use 1 and 1. Could you figure out the hypotenuse then? It'll be 1 squared plus 1 squared equals c squared. And 1 plus 1 is 2 equals c squared. Now technically when you square root both sides, you're supposed to put plus or minus. But why is it only it doesn't make sense for a length to be negative, right? Algebraically, when you square root, you have to add plus or minus. But mathematically, only the positive one makes sense. So now, could you figure out, like, first of all, type in sine of 45 into your calculator. Okay, and when you type it in your calculator, what do you get, 0.707 or something like that? And if I said you have to know how to do all those decimal places without a calculator, you'd be like, how's that possible? Well, if I look at my triangle, sine, I pick a 45, sine is the opposite side over the hypotenuse. Ooh, in our square roots unit, are we allowed to keep the square root on the bottom? Nope, so we're going to have to rationalize here. And if you type root 2 divided by 2 into your calculator, you will also get 0.707. And cos of 45 is also going to be adjacent over hypotenuse, which is also equal to root 2 over 2. Now you know how Sean picked 3 at the beginning, right? If I made this triangle bigger with 3 here, and 45, 45, and 90, and I did a squared plus b squared equals c squared, again, only the positive one makes sense, square root of 18, and now I did sine of 45, I would get opposite of 3, and hypotenuse is the square root of 18. I should get the exact same answer. So the question is, are these answers the same? They are, but how do we do that? Let me see. We can simplify that 18, yes. 18 would be 9 times 3 root 2. Can you see that those 3's would simplify? And then we get the same 1 over root 2, which is root 2 over 2. It wouldn't matter if you pick 1s, 2s, 3s, whatever number you pick, it'll simplify to be exactly the same thing. Just 1 works out really nice for mental math. So this is the first value that you have to do without your calculator. You have to know sine of 45 degrees, cos of 45 degrees, and tan of 45 degrees. Some people just memorize them. Some people say, hey, I can easily redraw my triangle to figure it out. That's the next one we're going to do. Sine of 30 degrees is 1/2. Okay? So, special triangle number 2. You make a right angle triangle, and you make an angle 30 degrees. And so that makes the other angle 60 degrees. This is a right angle triangle with all 3 angles different and all 3 sides different. This is like the majority of triangles. If you draw a random triangle, probably you'll draw all 3 angles different and all 3 sides different. The most common triangle. Because it's so common, some people will be like, well, you're so common, you're not really that special. Like there's special triangles, but this one doesn't fall into special triangles. Like isosceles is a special triangle. Well, there's another special triangle that I think you know. Do you know the name of another special triangle? Equilateral. What does an equilateral triangle have? All 3 sides the same. All 3 angles 60 degrees. Hey. Does anyone know the name of a triangle where all 3 sides are different? Like these non-special ones. They're called scalene. Even the name sounds like this. It's like, you feel bad. I always feel bad for these triangles because they're like, we have no special properties. We have everything's different. Nothing's the same. So here's this, this triangle. It's feeling a little sad because it's scalene. And this triangle is just walking down the street and comes across another scalene triangle, identical to it, also feeling sad. And they're like commiserating together and like, yeah, well, I'm feeling sad, and the other triangle, yeah, I'm feeling sad too. Well, do you want to be friends? And the 2 triangles said yes. Let's be friends. So I'm gonna draw this triangle's new friend right beside it. Okay, they were exactly the same. Also 90, also 30, also 60. They're holding hands there. It's really nice. It's good. This has a very happy ending to the story. So these 2 triangles, they get together, and then something special happens. Do you see the special thing that just happened when they got together? What did it make? An equilateral triangle. So that means in that big triangle, all three sides have to be the same. All three angles are 60 degrees now. So we can, again, pick any number we like. But some numbers are not going to be really nice for a squared plus b squared equals c squared, right? I probably wouldn't choose 317 for one of the sides. But a really nice number to use, like we used 1 last time, this time 2 is really nice. Why is 2 really nice? Can you see what's going to happen on the bottom? 1 and 1. And then if I do a squared plus b squared, right, equals, and this time I know the hypotenuse is the 2, then I get b squared equals 3, and b would be plus or minus the square root of 3, which again, only the plus part makes sense. Put it in purple here, that height is the square root of 3. And now there's 6 more things you can do without a calculator by knowing this one triangle. You can do all the trig ratios for 30 degrees. Right? Pick a 30 degrees. Sine, SOHCAHTOA, sine is the opposite side divided by the hypotenuse. 1/2. You can check it on your calculator. If you type sine of 30, you get 0.5. If you do cos of 30 degrees, adjacent side, root 3 over hypotenuse 2. 0.866. If you do cos of 30 degrees on your calculator, you'll get 0.866. If you do square root of 3 divided by 2 on your calculator, you get 0.866. And then tan of 30 degrees. Go to the opposite side, which is 1, over the adjacent side, which is root 3. Of course, we have to rationalize. If we would have done trig before we did square roots unit, we wouldn't know how to do that yet. But we get root 3 over 3. And then we can do exactly the same thing with 60 degrees. I'll do them quick here. Root 3 over 2, cos of 60 degrees, 1 over 2, and tan of 60 degrees is just root 3. You can write over 1 if you want. So again, you have to know all 6 of these without your calculator, which you can do by knowing one triangle. If you know the one special triangle, then you can figure out all 6. Or you can just remember all 6 of them. Okay, circle questions 5 and 6, because they involve non-calculator stuff with these special triangles. But we're going to do example 1 together. And this example 1 is a calculator question. The point 3, 4 is on the terminal arm of an angle in standard position. So I'm going to take out my highlighter. I'm going to highlight the fact that we learned what standard position was. It has to start on the x-axis. It ends at 3, 4. So I'm going to draw a picture of this. Here's my crosshairs. 1, 2, 3, 1, 2, 3, 4. Here is the point P, 3, 4, and that is on the terminal arm of an angle in standard position. So the standard position means this is my angle theta right here. How does this deal with trigonometry? Well, we have to see if we can draw a triangle to help us figure things out. And we're going to find that we almost always, well, we will always draw a triangle back to the nearest x-axis because that includes the angle theta. And I already know since this is over 3 that this length is 3. And since it was up 4, this length is 4. And then we can do a squared plus b squared equals c squared, because that's what question A is asking. It's saying, what is the distance from here to here? That's just the hypotenuse of that triangle. And we can do a squared plus b squared equals c squared, and something special is about to happen. I don't know, this is like one of the most famous triangles in the world. It's important to recognize. If you see it on the street, you'll want to get an autograph or something. Okay? A squared plus b squared equals c squared. 9 plus 6, this is 25. Oh my goodness, look what happens here. Of course, when you square root plus or minus, but the minus doesn't make sense. This is 5. And what makes this triangle so famous is that all the numbers are nice numbers. There's actually a bunch. You want me to get, maybe I'll get off topic right after this question and show you some other famous triangles. Okay, but this is the first one, the 3, 4, 5 triangle. So that's part A. Part B, I'm going to take out my highlighter again. First of all, I want you to read it and ask yourself on a level from 1 to 10, 10 extremely confident, 1 I don't know. When you read that question, do you know what to do? Do you know what they're asking when they say primary trig ratios of theta? Right? If you're very confident, right? This is a 1. This is a 10. When you put your hand up, how confident you're feeling on primary trig ratios of theta. If you put your hand up a little bit, and you like this, or you like super confident. Now you're nervous, right? Because you think you put your hand up, and I'm gonna. Oh yes. What would you like? You want? No, I'm not gonna. This is the important thing about math. Sometimes, like if I just do the question next, you would all be like, that's super easy, and write it down in your notes and feel really confident. And then you get to a test. Does this ever happen to you on a test? And you read a question, you're like, oh my goodness, I don't know what those words mean. And then you get stuck. So when it's asking for the ratios, it's asking for the SOHCAHTOA. Can you write sine equals, and then write the ratio? A ratio is a fraction. Can you write the fractions for each one? So in B, they want me to write what sine of theta is. They want me to write the ratio. So I look at my triangle. SOHCAHTOA says sine is the opposite side over the hypotenuse. I want to do cos of the angle. That would be the adjacent side over the hypotenuse. And I want to do tan of the angle. That would be the opposite side over the adjacent. And then finally in part C, we want to find the actual angle. And we have 3 equations. You could use any one of those equations. They're all going to give you the right answer. But technically this one is the best. Because it doesn't use the 5, and I wrote the 5 in purple to remind us, we solved for the number 5. Whenever you solve for something, there is a chance we made a mental math mistake. I assure you I didn't. I know that your confidence is pretty low lately, but no, 5 is right. I got the 5 right. But if we use the tan, we're guaranteed those are numbers given to us it should work out perfectly. So how do we find theta then? Well, we would go to our calculator and we type in tan inverse of 4/3. And I've already got it set up on here in the calculator. No, it's off. I'll move it up. I think I've got it set up here. There it is. Tan inverse of 4/3, 53.13. But I'm just showing you here that if I did the sine inverse one, I get the same answer. Or if I did the cos inverse one, I get the same answer. So that means that number 5 was right. We did a squared plus b squared equals c squared correctly. Whew. Okay, I'm going to get you to circle 3 and 4, 8 and 9, and 10 and 12. And then I told you I would introduce you to some more famous triangles. So, the first famous triangle that we just saw was the 3, 4, 5. I feel like drawing it like this. It's still famous if you draw it that way. 3, 4. The next famous one is the 5, 12, 13 triangle. 5 squared is 25. 12 squared is 144. 144 and 25 makes 169, which is 13 times 13. I'm going to show you the third one, and then I'm going to tell you, you have to tell me the fourth one. So the third famous triangle is 7, 24, 25. And you have to tell me something about the fourth famous triangle, where all the numbers are nice whole numbers. Even if you can only tell me one side.
9, 48, 49.
Ooh, close. You got the 9. 40 and 49 is not quite as close. I like what you did. Did you take 48 because it was twice this? And 12 doubled to get this? But does 4 doesn't double to get 12? So the pattern, you're right, on the right track looking for patterns. Has to work all the way through. 8, 6, and 10 is this one doubled. So it's still famous, but it's connected to this one. But Joe's right that we have a 9 here. What do you think?
Is the bottom one, is it 24?
24 and 25? No, the 24 and 25 fit with this one. But they don't, there's different numbers on that one. See if you can figure out a pattern.
$36.
36 and 37. Did you go, what was your pattern? You added 12? But we don't add 12 here. Close. You're on to good patterns. You guys are looking for good patterns, but the pattern has to fit through all of them in order to work.
Is it 72?
72 and 73? No. 40 and 41? Yeah, okay. 40 and 41. Alright, now I can find the next one. See if you can see the pattern. Anybody guess one of the sides of the next one? 11. Oh. I think you're figuring out this pattern pretty good, right? The other one's a little harder. Oh. Marcus has found the pattern. What did you do?
So I see the first one
Went up by 8.
So I just added a 4 to 12.
Oh, 8. Went up by 8. You see what he's saying? And then it went up by 12, which is 4 more. Then it went up by 16, which was 4 more than last time. Then it went up by 20, which is 4 more than last time. Now, that's wonderful, but I'm gonna create a problem. I'm gonna skip a bunch and just say, is there a way we could figure this out if you just knew this number? In other words, if I know 9, how could I figure out those two? If I knew 5, how could I figure out those two? Is there a pattern that you could just use directly to figure out the other two numbers, rather than using the previous pattern? Hmm? Yeah, but that's using the previous one, so we're using arithmetic to find it. I'm just saying, I got 25. Can you just use the number 25 to find out the other two numbers? How could I just use the 5? How is that related to the 12 and 13? How is 9 related to 40 and 41? How is 7? Is there some sort of connection between those two numbers? And it's a connection that I know that you all know, so it's like, once you see it, it's like, oh. How is 9 connected to 40, 41? How is 5 connected to 12?
312 and 313.
It's 312 and 313 here. Oh my goodness.
Is it because if you add up the two numbers, it's that number
Squared.
squared?
Yeah. 9 squared is 81. 5 squared is 25. 7 squared is 49. 11 squared is 121. Now, you'd have to go to your calculator and do 25 squared and get 625. If you cut it in half, you get 312.5, so one has to be 312. One has to be 313. That's pretty cool. These are famous Pythagorean triples. All right. Sorry I got off topic. Would you like time to work, or do you want me to just keep getting off topic?